This video will be about separable differential equations. So we mentioned last time that a differential equation is something in the form y prime equals a function of x and y. So in some cases, in order to solve for y, we can use a technique called separation of variables. And what you do is you move all of the y's to one side, and you move all of the x's to the other, and integrate as normal in order to get y. So we can look at an example of this. Let's say that y prime equals 3x. So what we can do here is replace y prime with dy dx. And so now we want to get all of the x terms on one side and all of the y terms on the other. We can do this easily by just multiplying through, so we get 3x dx. And at this point, we can just integrate both of the sides. So we get a y plus a constant c equals 3 over 2x squared plus a constant c. And since there's a constant c on both sides, what you can do is just write 1c. So you can just say that y equals this. In order to truly solve for y, we need to get rid of c. In some cases, when we're given the differential equation, we're also given an initial value along with it, which is usually something like y of 0 equals a number. And using that, you can solve for c. So taking our example from last time, where we had y prime equals 3x, if along with this condition, we're also given the initial value, saying y at 0 equals 1, then after we solved our equation using separation of variables, where we found y equals 3 halves x squared plus c, we can plug in our initial condition. So that would be y at 0 equals 1, it's 3 halves 0 squared plus c. And so now it's easy to see that our value, c, equals 1, meaning that our complete solution to our differential equation is y equals 3 halves x squared plus 1. Remember last time that we were talking about exponential growth, which is something in the form y equals some initial value yo times e to the rt. But if we think about a population's growth, then usually it doesn't actually increase exponentially, or else all of the world would explode. What happens is that there's usually a carrying capacity that limits how much the population can actually grow. And the carrying capacity is determined by just biological factors, like the amount of predators, the amount of space, and the amount of food available. In math, we're going to call the carrying capacity K. And in order to take into account this carrying capacity into a model of a population, we use something called the logistic equation. And so the way the logistic equation looks is y prime equals ry times 1 minus y over k. And since we're talking about population here, we can just replace the y's with a p to denote population, so we could write it also in this form, rp times 1 minus p over k. So again, in this equation, we have p representing, well, p prime representing population growth, r representing the natural growth rate of the population. And note that this r for any population is the same as the r that you would find with the exponential equation, meaning that this is the growth rate if there were no carrying capacity and no limit on the way that the population could grow. Okay, again, P here is population, and then K is carrying capacity.